Welcome to qnawire.
So let's draw our general scheme. So here on my y-axis I have my enthalpy, and here on my x-axis I have my reaction coordinate, or you could think of it as time, which indicates the progression of my reaction. And so here in the reactants I have my ionic compound in its solid form, sodium iodide, and I know that the dissolving of sodium iodide into a solution is exothermic, and so my end products are gonna be at a lower energy than sodium iodide. And here I have them after dissolving in water in their aqueous ionic form. All right, now there are two processes we could think of like that will bring my solid sodium iodide into its aqueous form. First, I need to break them. And breaking the lattice, and as you could tell, hence I would get delta H lattice, is going to be positive. It requires energy. And in general, the general definition of the lattice is that I break the lattice in its natural state at room temperature, which is in this case solid, into its ionic gaseous state, right? And this is positive. The next step, so here I could have delta H solvation is equal to delta H lattice. That's the first part, which is positive. The next part is going to be the delta H of hydration, which is the energy released when intermolecular forces form between my ions and water. And as you could see, my total delta H of solvation, delta H, let's call it S, is negative. This, so here I have delta H lattice plus delta H hydration. And this is less than 0, which means that this is more negative than this is positive. In other words, the magnitude of delta H hydration is greater than the magnitude